Now problem number 19 is, a proton and electron are accelerated by the same potential difference. If lambda E and lambda P denote the de Broglie wavelength of an electron and proton respectively, then which of the following option is correct? We are going to verify. Now first of all, de Broglie wavelength can be expressed in many ways. Lambda is equal to h by P, lambda is equal to h by mv, lambda is equal to h divided by square root of 2m into E kinetic. I am going to write that. So lambda de Broglie wavelength is equal to h divided by square root of 2m into E kinetic. This is one of the equations. This can also be written as h divided by square root of 2 into m into, instead of kinetic energy I can write E into V, because here we are given that what potential difference. So I am going to associate that term potential difference. So for electron, okay, for electron I will take for an electron. First equation I will write for an electron. So de Broglie wavelength of an electron is equal to h divided by square root of 2 into mass of the electron into charge of the electron into V. Okay, so this is now charge of the electron and proton, both are one and the same except the sign. Both are 1.6 into 10 power minus 19 coulomb. So my dear students, you don't use the suffix E1 here. So only the mass M1 or Me I am writing for electron. Similarly for this next particle is what? Proton. Okay, proton. I will take this is for a proton. If you write the same equation for a proton, means what? The de Broglie wavelength of a proton is equal to what? H divided by square root of 2 into the mass of the proton is mp into charge of the proton is the same, is it not? E. So potential difference also is the same, like this. Okay, I will divide on both sides. I will divide on both sides. Therefore what is this? Lambda E divided by lambda P is equal to, so it is right hand side, if you divide means what will happen? This denominator will come to the numerator. So this is equal to square root of 2mp. So 2mp into EV divided by square root of 2me into charge of electron E into potential difference V. So which will be cancelled here? 2 is getting cancelled. Charge of the electron and proton get cancelled. The same potential difference V also is getting cancelled. So now we get this is equal to square root of mp. So mp divided by me. What do you mean by mp? Mass of a proton. Okay. But mass of a proton, okay, mass of a proton mp is equal to 1846 times the mass of an electron. Okay, students. Therefore, lambda E by lambda P is equal to, this is a square root of, okay, this is a square root of 1846 into me divided by square root of me. So that these two get cancelled. So this is equal to what? Square root of 1846. So naturally lambda E must be root 46 times, 1846 times. Therefore lambda E is equal to square root of 1846 times that of lambda P. That means it is greater. So lambda E is greater than lambda P. So this is lambda E is greater than lambda P. Now we see the four options. Lambda E, okay, lambda E is greater than lambda P. So which option is correct, my dear students? Option D is correct. So we will write here option D. Okay, students. So this is option D is correct. Fine. We will go to the next sum.